cubic polynomials. Our objective, we want to define cubic polynomials, and we want to recognize the characteristics of their graphs. So first, let's give a definition. What is a cubic polynomial? It is a polynomial with the highest degree being 3. They are also called degree 3 polynomials or third degree polynomials. You'll see all of those terms used interchangeably. So now let's quickly recognize some characteristics of their graphs. And I've got 3 examples here of degree 3 polynomials, cubic polynomials. The first graph is the parent graph, which is y equals x to the cubed, x to the third power. This is the simplest of the degree 3 polynomials. And then here's a graph of x cubed minus 5x squared minus 2x plus 5. So this one has all the pieces, an x cubed, an x squared, an x, and a constant. And here's a graph of simply a cubic, which is negative 2x cubed plus 6x squared. And just kind of notice the end behavior. The ends, here's an end and here's an end. Here's an end and here's an end, for example, here. The end behavior is opposite. Okay, the opposite of one another. And let's notice a couple things. We can have 0 turning points. So this one has what's called an inflection point, but doesn't turn there. And this, or it can have 2 turning points. So here's a turning point here, and here's a turning point here. And this one has 2 turning points. There's one here, and there's one here. So you can either have 0 turning points in a degree 3 polynomial, or you could have 2 turning points as you see here. A turning point is either called a local maximum or a local minimum. So this would be a local minimum, almost like a valley. Local minimum, hope I spelled that right. And here's a local minimum over here as well. And this here and this here would be a local maximum, kind of like a small hill. So here is a local maximum. Just a couple of things to recognize with the graphs of cubic polynomials. And the second thing we want to note here is that because the end behavior is opposite, we're always going to cross the x-axis at least one time. As you can see in this first graph, it only crosses one time. But the graph can have 1, 2, or 3 x-intercepts. Again, here's an example of 1 x-intercept. Here's an example of 2 where it came down and it touched the x-axis, and then it went back up, and then it came back down and it crossed the x-axis. So this one has 2 x-intercepts. And here's an example of 3 x-intercepts. It comes up, it crosses here, comes down, crosses here, comes down again, goes back up, and crosses here. So a cubic polynomial can have 1, 2, or 3 x-intercepts.